Learning derivatives.
Yay!
We are on to the second major topic of calc, integrals.
I thought he was doing notes.
AJ, go sit down. We're starting our notes.
Oh, we are?
Yeah. Yes. That's why you had a time limit. Okay. That's okay. So we are on integrals. Oh, I'll back up a second too. We're done learning anything new about derivatives, but we're not done using them. So you've learned everything possible that would on finding derivatives and how to use them. We're the second portion of calc now. It's called integrals, but another name that it can go by is antiderivatives. So it doesn't mean anti as in like dislike, right? It's the opposite of derivatives. Integrals is by far the most common name, so I'll traditionally use that. We aren't going to actually even learn how to find integrals until we come back from spring break. So we're purposely trying to finish 6, 1, 2, and 3 before break, because those 3 sections are basically like the big ideas behind what you're going to use them for. And I am pretty much counting on the fact that a lot of you are going to forget everything over spring break.
Sweet.
So the three sections we learned before break aren't going to be necessary for us to learn how to start finding integrals after break. That's why we thought it would be a good split spot. Okay, yes. Yes? The Thursday before spring break. Okay, so let's look at this first question in section 1. And don't worry, you don't need to use much brain power today. This is why this is fine to do after the test. I know that your brain is worn down currently. So we'll start by this, and I'll go off topic. It says, let's take a look at the relationship between the graph of rate of change function and the area of the region between that derivative graph and the x-axis. Consider the tropical cyclone Imelda. I thought this was weird because I don't think I've ever heard anybody use the word cyclone in a sentence ever. And so we took the time to look it up in second hour. No, I mean, I thought it was a typhoon. I had them backwards. So cyclone apparently is a generic word that means hurricane or typhoon. And then this brought us on to the topic of flushing water. Because hurricanes are a northern hemisphere thing, typhoons are a southern hemisphere thing. And that was always my favorite fact that blew my mind about science, right? Like in the northern hemisphere, water swirls one direction. The southern hemisphere, it swirls a different direction. No matter how hard you try, you can't get water to swirl a different direction. And I don't know if you guys have seen the video, but there's literally the one spot on the equator where you can go where it won't swirl. And if you take a couple steps the one direction, it'll start swirling the one way. Take a couple steps the other, and it'll swirl the other direction. I thought that was super cool. It's totally meaningless and is not going to matter, but I always thought that was cool. So I'm going to change this word to hurricane because that's what we have up here.
No. That literally has no.
And I don't know if any of you guys, are any of you guys from southern states? Like I've never been part of a hurricane. Like apparently they bring a lot of water.
Yeah.
You know, the only flooding we really ever get around here is the Red River or the St. Croix River.
Yeah.
So this whole problem is about pumping out a lot of water, because it talks about how they started off pumping out 500 gallons per hour, which sounds like a lot. But then apparently they needed a second pump to pump out 900 gallons per hour for the next 16 hours, which tells me that they had a lot of water.
That's a lot of water.
So if that amount of water is in your house, it's generally not good anyway. So we are going to graph. Yeah, I don't know what is going on out there, but we're gonna graph what this situation talks about. So let's make the bottom axis about number of hours, because it's referencing hours in the problem. And then this graph is specifically about a rate of change function. So this is gallons per hour. Now, we've already done this year. We started teaching this ahead of time. I suspect some of you can already figure out what we're going to do with this. We did it during position, velocity, and acceleration. We're going to be finding area under the graph. So if I have gallons per hour and hours, we basically multiply to get area. So that would tell us total number of gallons found. Okay, so if we draw what this situation says, it's basically the easiest graph you've ever had, right? It's 500 gallons per hour for the first 8 hours. So that's what that rectangle would show. And then they added a second pump, which was probably a different size because it's not doubled. And it goes to 900 gallons per hour for the next 16 hours. So literally 24 hours of pumping water out of your house can't be great. And that's why I'm very thankful I've never had to do it. Okay, area under the curve is the phrase that gets used a lot. And I believe I used that same phrasing before when we did this. It technically means the area between the function and the x-axis. So if your function is below the x-axis, you would measure up towards the x-axis, and then it would be a negative answer. Okay, so what? We have 500 times 8, I believe that's 4,000. So we apparently removed 4,000 gallons in the first 8 hours, and that wasn't enough. 900 times 16 hours. It's less than 1,600. It's 900 less than 1,600,000.
14,400 gallons.
I was not right. Oh, yeah, no, that's, shouldn't it be 900 less than 16,000? Am I thinking wrong? Obviously I am.
Is it just 900 times 16?
Yeah,
Yeah.
14,000.
400.
In my head, I was doing 1,000 times 16. So, oh, never mind. It'd be 1,600 less. Yep.
Okay.
I was trying to do mental math.
It's okay.
Yeah, my brain's worn down. That's what happens when you get old. 14,400 and 4,000 gallons together, so we get 18,400 gallons that was removed from this house. Again, we've done this before. We just did it for total distance because we would do velocity and time, so that gave us distance. Now, this method actually has a specific symbol that goes with it, okay? So just like when we were doing derivatives, the symbol for derivatives was d dx. The integral symbol is called the integrand. The integrand. It looks like a distorted S with little things on the end. It reminds me of a music symbol that's weirded out,
Yeah.
like a symbol on a violin. But that's called the integrand. And if you see this symbol It's supposed to represent that you know you're adding up the area or something similar like that. The way we would write this is we would say the integral from 0 to 24 hours of our function. Now, this portion at the end you're not going to get, and that's fine, but you have to write a dx afterwards. And the answer to this would be 18,400. So this symbol would tell us to add up the area that's there. Was this the class I told about me taking jewelry?
Yes.
Yeah, that was the symbol I made on the ring.
Nice.
Yeah, it was cool. I had
That's
an
cool.
I had an integrand symbol above a summation symbol, and it was
So,
yeah. I got an A on it. I got an A. Do I still have it?
yeah.
No.
Why wouldn't you keep that?
I didn't care.
Oh, damn. Right.
I mean, like, I don't wear a lot of jewelry.
Yeah. I mean, I don't know. It'd be cool.
I'm pretty sure I gave it to one of the professors. Yeah, well, I worked in the math department, so I knew a lot of them.
How'd that work out?
Now, we only have a couple minutes left, right?
Yeah.
Perfect. Oh, is this that bad?
Yeah.
Wow. I know it's Friday. My voice needs spring break coming up here. I'm starting to lose my voice a lot here. Okay, so it was super easy. Henry, what are you doing? It was super easy when our shape was a rectangle. But virtually every function we ever have is not rectangular or geometric. Would you guys put your phones away? We only have 5 minutes left.
We're tired. I don't
Yeah, me too. I'm still teaching.
know. You could just like not teach.
That's the difference between not being an adult and being an adult.
That's
You do it even if you don't want to. We still are going to be estimating with rectangles. But like looking at that picture, you can tell that it's not going to be a great estimate. There's a whole bunch of chunks that are above the graph. There's one that's below the graph. So it's not going to be a great estimate. Can anybody think what we could do to make it a better estimate? Thinner rectangles? Absolutely. So like our first picture, we used 2 giant rectangles. This one's got 5 rectangles that are whatever, 1 width. We could use a lot of rectangles that are very skinny. Now clearly, it's going to be super annoying to add all that up. Finding area of rectangle is not hard, but like it gets kind of old if you have to do 20 of them for like one picture. And so we are going to start with that. Also, do you notice how the right-hand side of each rectangle on this picture is where the function passes through? This is going to be one way of estimating. A different way of estimating is you can use the left-hand side of the rectangle instead, because that would choose to be a different height. You could also use the middle of a rectangle. Now, to me, this section feels really useless, because we're going to learn how to find the exact area. And instead, we're taking a lot of time to figure out how to estimate with rectangles. And it feels kind of dumb to do this, but it doesn't matter. 1, it's on the AP test, so you have to know how to do it. 2, strangely enough, this is actually what leads you how to figure out the exact area. It doesn't feel like it should, but it's going to. And that's what section 1, 2, and 3 are doing, teaching us how to do it with rectangles to get exact answers. And then when we get to section 4 after spring break, we learn how to do it without a picture, just equations. Okay, I'm done. We weren't going to have any homework. I'm assuming you knew that. You guys have been studying the last couple days quite hard, probably.